In this version we have included a new device for the calculation and design of water supply networks in buildings: the pressure reducing valve. A common situation in buildings of 10 or more floors is that the water networks located at the lower levels usually have high operating pressures. This is why it is usually decided to place, at the connection point of each network with the riser pipe, a PRV that allows pressures to be maintained below a maximum value. To show you the basic approach that we are developing in the new version of PLUMBER, we'll show the multifamily building project that we have already used in other tutorials. We have the typical layout of the most unfavorable apartment, that is, the furthest away from the connection to the riser, which is located at this point. Also, for the purposes of performing the vertical distribution, we have a riser in the respective tab. Which, as you'll see, supplies to 10 levels. With 4 typical water networks in each level. In this case we have a riser supplied by pumping, that is, it is of the ascending type. And, as I have told you, you will see that, certainly, the lower levels have pressures that we could consider high, at least as far as user comfort is concerned. Then what we have done, in order to determine which are the levels that would require pressure regulation, is to insert a PRV between these two nodes. It is worth saying that, if we go to the Configuration tab, Devices panel, we have the button to access the Pressure Reducing Valves Manager. In this case, for the automatic definition of the diameter of this device, you must specify, based on the information available in catalogs, what is the maximum flow that each nominal diameter can convey. So, when we go to the PRV properties here in the drawing, keeping, just like as with the pipes, check the Calculate Diameter box, the program will determine from that table the diameter, based on the probable flow rate conveyed by the pipe section. You will also see here that, if you check this box, you have the option of enter a total head loss value for the valve. In this case, the automatic calculation of the necessary head loss in the valve is overridden, forcing in the calculation to fulfill the value you enter here. But, if you choose to uncheck it, the program will determine what is the necessary head loss value so that, downstream of the valve, the maximum pressure specified here is not exceeded. Let's see what we get in this case, considering that we do not allow the pressure to exceed 35 meters of water column in any water network. I click OK to save this configuration, and from there let's calculate. Once the calculation is done and, of course, coming back to the PRV's properties, you will see that, if I click this button, a table is shown. It is the table that tells us what the settings in each building's level should be to guarantee, on the one hand, the minimum necessary operating pressure, and, on the other, the maximum pressure that we have specified. Thus, we see that the first floors would require pressure reduction so as not to exceed the maximum pressure that we have previously specified of 35 meters. Also, as a design and selection parameter aid, we include the cavitation coefficient calculated for each condition. In this way, as you have seen, when you associate water networks, with reducing valves included, in the project's risers, you will be able to have this support table in your designs.